Welcome, everyone. Today we are diving into the science of glass. Glass is a material we take for granted every day, but it is one of humanity's most complex and sustainable engineering achievements. From its humble origins as melted sand to the sophisticated glass fins on modern skyscrapers, we'll explore how it's made, why it behaves the way it does, and how it's helping build a sustainable future.
It all starts with a recipe known as the master batch. While quartz sand is the primary glass former, it has an extremely high melting point. To make production viable, we add soda ash to lower that melting point, limestone for durability, and feldspar to protect the glass from the elements. This precise mineral cocktail determines whether the final product will be a wine bottle or a skyscraper facade.
To turn these minerals into glass, we heat them in massive furnaces to 1600 degrees Celsius. To put that in perspective, that is roughly 1/3 the temperature of the surface of the sun. At this extreme heat, the minerals lose their crystalline structure and transform into a glowing, viscous fluid, the molten mass that forms the foundation of all glass products.
Raw molten glass is full of bubbles caused by chemical reactions. In the refining phase, we add clarifying agents like sodium sulfate. These agents create larger bubbles that rise to the surface, effectively sweeping the microbubbles out of the liquid. This is what gives glass its crystal clear optical purity, free from the distortions or inclusions that would compromise its strength.
How do we get glass so perfectly flat? In the 1950s, Sir Alistair Pilkington revolutionized the industry with the float glass process. Molten glass is poured onto a bath of molten tin. Because glass is lighter, it floats on top like oil on water. Since the surface of liquid tin is perfectly level, the glass becomes perfectly flat on both sides, requiring no expensive polishing. As the glass leaves the tin bath at 600 degrees, it is still too hot to handle. If it cools too quickly, internal stresses will build up, causing it to shatter the moment it's cut. We pass it through a layer, a controlled cooling tunnel. This gradual temperature reduction allows the molecules to settle into a stable state, making the glass predictable, workable, and safe for architectural use. In modern architecture, glass has evolved beyond simple windows. Companies like Schuco use advanced glass fins and ALB systems, which you see in the section details here. These louvres provide passive solar shading. They block heat while letting in natural light, showing how glass is now a high-tech tool for energy management and structural aesthetics.
For engineers, the most important number to remember is 2.5. 1 square meter of glass at just 1 millimeter of thickness weighs exactly 2.5 kilograms. This constant density allows architects to calculate the load on building frames with absolute precision. Whether you are installing a 6 millimeter window or a 19 millimeter structural fin, the math remains consistent.
Glass is a superstar of the circular economy because it is 100% recyclable. Unlike plastic, it doesn't degrade when melted down. We use cullet, crushed recycled glass, as a primary ingredient. This reduces the need for raw mining and ensures that the glass in your window today could have been a bottle 50 years ago. While the world is full of sand, high-purity quartz sand used for glass is actually becoming scarce. As we build more cities, the demand for silica is skyrocketing. This makes our recycling systems not just an environmental choice, but a critical business strategy to protect the industry from raw material shortages. Recycling also saves a massive amount of energy. For every 10% of recycled cullet we add to the furnace, we reduce energy consumption by 3% and CO2 emissions by 5%. Because cullet melts at a lower temperature than raw sand, the furnace doesn't have to work as hard, making the process significantly greener and more cost-effective.
To wrap up, glass is a material defined by balance. The balance of ancient minerals, extreme heat, and precision cooling. As we look to the future, The focus is on sustainability. By mastering the float process and maximizing recycling, we are ensuring that glass remains the clear choice for a sustainable, high-performance world. Thank you. Please hit subscribe, and I'm happy to take any questions.